Welcome back to the second part of the pre-calc notes for 9.7. Remember, we're talking about probability, so as we look at this event, tossing a coin and rolling a six-sided die, what would be the probability of getting a tail and a number that's less than or greater than 2? So I want probability of a tail. The word and means times, and then the probability of a number that is less than, greater than 2, I mean. So on a die, I know that there are 6 different numbers, and the numbers that are greater than 2 are 3, 4, 5, and 6. A little bit neater. 3, 4, 5, and 6. So now I can think about probability of getting a tail. There's only one tail out of 2 different outcomes. Probability of getting a number greater than 2, there's 4 numbers that are greater than 2 out of 6 total. So that would be 4 twelfths, which is 1/3. Alright, now we're going to take a look at a more complex probability problem. So the question I have for you is, what is the probability that you would draw a full house in a set of poker hands? So first we need to understand what is a full house. A full house is 1 pair and 3 of a kind. So let's just say for our example that we're going to say that our 1 pair is going to be then the 2 kings, and our 3 of a kind is going to be 3 jacks. Okay, I'm just going to pick a specific hand, and I'm going to try to find all of the different ways that I can get that specific hand. So I'm going to be using the kings and the jacks. So what I need to do is I need to figure out what are all the different ways that I can get 2 kings in my hand. Now there's 4 total and I want to get 2. So this is going to be a combination problem. So I'm trying to find all the ways I can get 2 kings in my hand out of the 4 that are in the deck. So I would say for kings it would be 4 combinations of 2 at a time. And I'll times that answer then by all the different ways that I can get 3 jacks in my hand. So there's 4 total, and I only want 3 of them, so it'd be 4 combinations of 3. So when I do that, 4 combinations of 2, that's 6. And 4 combinations of 3, that's 4. That would be just the number of ways that I can get specifically 2 kings and 3 jacks. But my poker hand, a full house, can consist of, it doesn't have to just be kings and jacks. So when I'm thinking about picking my 2 of a kind, there are actually 13 different cards that I could pick as my possibility for the 2. So I could have used aces, kings, queens, jacks, 10s, all the way down to the 2s. So I actually have to take this number and times it by 13. Now once I've picked my suit, okay, so again, if I picked, I shouldn't say suit, I should say my card. Once I picked my king, then I only have 12 left over to pick for my third, or my 3 of a kind that I have left over. So that means if I've used this, the king, so I'll cross those off, I only have 12 different numbers that I could possibly put in for my 3 of a kind. So I have to times this number by 12. So that's going to give me 78 here and 48. And so I'll multiply those together to get all of the different possibilities of the full house hands that I could get in my poker game. So that's going to end up being 3,744. Okay? So if I'm trying to find the probability, that's not my answer. That's just all of the ways that I can get a full house. So if I'm using this formula now, I'd have to do 3,744 over all of the possible poker hands. So now I got to figure out what are all the possible poker hands in a deck of cards. So a poker hand consists of 5 cards. And again, specifically our full house was 2 of them were 1 of a kind and 3 of them were, or 2 of them were a pair and then 3 were 1 of a kind. That was getting me my 5 cards total. So if my poker hand can be 5 cards, I can pick any 5 cards from here. So I would find then all of the possibilities for the poker hands of being 52 cards total, and I'm going to choose 5 of them at a time. So this would be 3,744 over. Type that into the calculator. I get 2,598,960. So now I've got the number of different full house hands that I can get over all the different combinations of cards that I can get with the 5 in my hand at a time from the 52 total. And if I reduce that, my probability of getting a full house would be 6 over 4,165. So if you're kind of following along with this later on, if you're going back to look at this, the first thing that we did was we had to figure out how to specifically get one hand or one specific full house. Then what we did is we had to recognize that I could get 13 different cards for my one pair, and that would leave me 12 different types of cards that I could have for my 3 of a kind. And then I multiplied those together to get the 3,744. Then I went over here to this probability formula and I plugged in my probability formula. Fifth thing I had to do was figure out all the possible hands, and then finally the sixth thing I did was get my answer. It'll be useful when you go back and try to figure out how we solve this. Okay, so the next one says a salesperson makes a sale at approximately 1/3 of the offices she calls on. If she visits 4 offices on a given day, what is the probability that she will make a sale at all 4 offices? So basically what I'm asking you to do is find the probability that she makes a sale and another sale and another sale and another sale. Okay, so when I wrote it like this specifically so we could see the word and remember and means multiply. So the probability that she makes a sale 1 out of 3 times. So it'd be 1/3 times 1/3 times 1/3 times 1/3. So she's got one out of 3 chances every time she goes to the office. So she would be, if she goes 4 times, it's 1/3 times 1/3 times 1/3 times 1/3, which is 1 over 81. Okay, what if it says now, what is the probability that she, again, she visits 4 offices, so what is the probability that she makes a sale at none of those offices? Well, first thing we have to understand is that if she makes a sale 1 out of 3 times, the probability that she makes no sale would be 2 out of 3. So if she's making a sale 1 time out of 3, 2 of the times she's not making the sale. That's why the probability of no sale is 2 out of 3. So what I'm trying to figure out here is the probability of no sale, and I'll just abbreviate no sale, and no sale, and no sale. Again, I specifically wrote out the word and, so we recognize that that means multiplication. So this would be 2/3 times 2/3 times 2/3 times 2/3. And that would be 16 out of 81. And finally, the last one says, what's the probability if she visits 4 offices that she would make at least 1 sale? So understand what this means. At least 1 sale means that the probability that she would make 1 sale, or 2 sales, or 3 sales, or all 4 sales. So I could take the time to figure out the probability of 1 sale, and then add to that the probability of 2 sales, and then add to that, because I'm using the word or, 3, and then add to that 4. Or the easiest way to do this would be finding the complement. So the complement would be the probability of no sale. So what I'm going to do is I'm going to do 1 minus the probability of no sale to get my probability of at least 1 sale. That's the formula that I'm going to use. Well, didn't I just calculate the probability of no sale up here? Isn't this the probability of no sale? So therefore, all I have to do is do 1 minus 16 over 81 to get my probability of at least 1 sale. So that would be 65 out of 81. So this is a great example of where the complement is going to work out a lot better, especially since you've already calculated what you needed to use to be able to solve this. So that's why I would recommend sometimes using the complement, because we could definitely go through and find 1, 2, 3, and 4, but then there'd be a lot of work involved in that, and then we have to add all 4 of those answers up. And if we did that, we should get 65 out of 81. Much quicker to do the complement. If at least 1 is what I'm looking for, the complement would be none. No sales whatsoever. And again, I had already found that, so that's why I chose to go that route.